Now let's try to design a small computer with as small memory as possible and as few registers as possible, just to keep it simple so that you will understand what is going on in a computer. Let's take a small computer like this. Assume that the computer that we are going to design has a memory, and the size of the memory is 4096 by 16 bits. So meaning of this one is the number of words present in the memory is 4096, and we know that 4096 is nothing but 2 power 12, right? So 2 power 12 is 4096. Therefore, in order to address a particular word in this memory, the number of bits required will be 12. So the address has to be 12 bits. Got it? And what is the second part? This means that size of each word is 16 bits, right? So whenever you either issue a read or write, you will be doing it in units of 16 bits, right? You will be trying to write 16 bits in one memory cycle or read 16 bits in one memory cycle. Got it? And along with this memory, we are supposed to have the registers, right? So just for the sake of simplicity, I'll take as few registers as possible to implement a computer with as little instructions as possible, which will give us the rough idea about how a general purpose computer is designed and it works. Okay, so assume that I'm going to have these registers. One is DR, the data register, and other is AR, address register, and the other one is AC, accumulator. So let's talk about one by one and then we move ahead. So data register is a register which will be used to hold an operand which you get from the memory, right? So what should be the size of it? Since we are going to access the memory in 16-bit units, the size of this register has to be 16 bits. Therefore, assume that size of this register is 16 bits. So why is it used? Data register is used to store the operands which we fetch from the memory, so that we can pass these operands to the ALU. Got it? So it will be connected to ALU directly, right? So what is ALU? Where the operation will be performed. Got it? And now the next one is address register. So AR means address register. This register is used to store the address using which we will access the memory. Got it? So address register has to contain all the address bits. Now in this case, the number of bits required for addressing is 12. That is what we decided, right? So 12 is the size of this register. Got it? Now this register is having 16-bit size and this register is having 12-bit size. Now when you connect all of them to a common bus, what happens is the bus size is going to be 16. Then how will the transfer happen from here to here? Then anytime when you are talking about a 16-bit bus but a register is having only 12 bits, then the least significant 12 bits are transferred onto the bus as it is, and in the most significant bits which are required, which are not present in this register, they will be filled up with zeros. Got it? So which means if you are trying to transmit any information onto 16-bit, the least significant 12 bits will be filled up with the data which is present in AR, but the most significant 4 bits, they will be left as 0000. Got it? And the next one is accumulator. AC means accumulator. In most of the cases, we are going to have a processor is going to have a specific register which is called as accumulator, which will hold the output of any operation that is performed in the ALU. For example, if you have performed an addition, now the output of the addition will automatically be stored in ALU, this accumulator. The reason is ALU will not be connecting to the bus directly. Therefore, if you have to transmit the result of an operation from ALU to the bus, we are going to transmit it to the accumulator, and from accumulator we are going to transmit it to the bus. Got it? So anyway, when I show how it is connected to the accumulator and bus, you will understand, the ALU and bus, you will understand its actual operation. So assume that it is also 16-bit. And the next one is IR, instruction register. Now generally instruction register is used to store the instruction that we fetch from the memory. Got it? Why should we store it is because we have to store it and then analyze it and understand what that instruction is. That is called as decoding. So in order to do the decoding, we have to store it in a register, and now that register will be connected to a decoder directly, so which will say what this particular instruction is doing, and the size of this register should be equal to the size of the instruction, or at least it should be equal to the size of the maximum instruction that can be present in the computer. So in this case, let us assume that we are using the instructions of size 16 bits. Okay, assume that we are using instructions of size 16 bits, 0, 1, 2, 3, so on, 11, 12, 13, 14, 15, like this. Okay, so assume that this is instruction, and now instruction, since it is 16 bits, our instruction register also has to be 16 bits, right? And in this 16 bits, 0 to 11, which means these least significant 12 bits, they are used to represent the operand. So assume that we are having instructions which can have at most one operand in the instruction. Got it? So when we have only one operand in the instruction, then the space required is nothing but the address at which that operand is present. Since the address is 12 bits, that is why I'm giving 12 bit space to hold the address of the operand, and the remaining 4 bits, they are going to be useful to specify what type of operation it is. So that part is called as opcode. Got it? And since we have 4 bits for the opcode, you might think that 2 power 4, which means 16 different operations are possible. Yes, you are right, 16 different operations are possible. But then in this particular computer, what we will do is we'll even have 0 operand instructions. In that case, what I do is, if the operand is not required, in that case I'll use even this part also to represent some of the instructions or type of the instruction. Then by adding these bits as well, I can increase the number of instructions possible. So even though you might think that it is 16 possible, I'm going to convert it into 25 instructions. So how am I going to specify 25 different instructions? Because sometimes I'm even going to use these bits. Try to understand this. Sometimes I'm even going to use these bits, and that is how I'll get 25 bits, 25 instructions. I'll tell you what those 25 instructions are. First, try to understand the registers first. Okay, and the next one is program counter. Now what is a program counter? It is a pointer which will say from where should we be loading the instruction from, right? So your program is always going to be stored in the memory, stored memory, right? Stored program architecture we are going to use, and assume that you have to start your program from here, 100. Then initially we load 100 here, the address of the first instruction. Now we fetch from this place, the instruction will be fetched into instruction register, and then at the same time it will be incremented to 101, and it will get ready to fetch the next one. Therefore program counter will always point to an address in the memory where the instruction is present, and since the number of bits required to point to a particular thing in a memory is 12, the size of this program counter has to be 12 bits. Got it? So in our computer we are going to use this address register, which is going to specify address of an operand as 12 bits, and also program counter, which is going to specify the address of an instruction, also 12 bits, because our memory is 4096 by 16. That is the reason. Got it? And the next one is TR, temporary register, which is used to perform some temporary, which is used to store some temporary data. So whenever we need to store some temporary data while computing something big, we are going to make use of this. Okay, and along with these are the main registers which will be useful in execution of a program. Along with that, if your computer doesn't have the capability to input and output data, it will be useless. That is why I'm going to have one input register and one output register. This input register will read or will get a byte from keyboard, and then it will pass it on to the CPU, that particular ALU, and from ALU it will get processed and get out onto the accumulator. From accumulator it will go and get stored in the memory, or it can get into the output register. Got it? So input and output. So input, let us assume that we are going to get it from the keyboard, and output, let us assume that we are going to write it on the screen, or we are going to print using a printer. So anyway, I'll assume that both are 8 bits, just for the sake of simplicity. That's it. So now I'll assume this basic thing, this basic memory and this basic registers, and then instead of using a full-fledged ALU, arithmetic logic unit, I'll use adder logic unit. So which means I'm not going to perform all the arithmetic operations like multiplication, subtraction or exclusive OR. I'll just perform few operations, so like addition. So I'll perform addition and some few logic operations. Therefore, let me call that unit ALU as adder logic unit. So just to keep them as simple as possible so that you'll understand everything, right? I cannot take a modern day computer and then try to explain you what is happening inside it. Taking a small computer and explaining is very easy. That is the reason. Okay. So now this is the entire things required. So we are going to connect all of them together, this memory, these resistors and that ALU. We are going to combine all of them together, and then we shall decide how to apply the timing signals and the other part like control signals, how to do that in order to do the manipulations. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities or 50 lakh universities, but whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.